You know sound has mass? Though actually the mass is negative. Nevertheless, it can interact with gravity, which means sound floats upwards. That means there is no sound in space by itself because space has such a low gravity, and there aren't particles close enough for vibrations. There isn't an emitting womb coming out of other planets, or the stars, or comets, or whatever. Again, because of the lack of mediums, air, water, and wood, for those vibrations to travel through. This, however, can be a misconception through the works that NASA has discovered through Voyager 1, the Perseus Galaxy Cluster, and Messier 87 Galaxy. On the Voyager 1 spacecraft, an instrument called Solar Orbiter Radio and Plasma Waves Instrument, or RPW, is used to detect vibrations of dense plasma or ionized gas. There were vibrations captured by the RPW instrument during October to November 2012 and April to May 2013. The frequency of the waves is the density of the plasma. It's color-coded for the intensity of each wave, red for the loudest and blue for the weakest. The dashed lines indicate the rising tones are following the same slope. Therefore, the density is increasing.
Have you ever wondered what a black hole sounds like? Well, NASA has you covered.
CNN covered news in 2022 about NASA's recording of a black hole sound, though back in 2003 in the Perseus Galaxy Cluster at the center, astronomers discovered the pressure waves dispensed by the black hole creates ripples in the cluster's gas. This is then translated to a music note. These notes are adjusted in order for humans to hear. The raw form is 57 octaves below middle C. Referring back to my opening statement that there is no sound in space because there aren't mediums for the vibrations to travel through. Well, a galaxy cluster has gas that provides a medium for the sound waves because of the galaxies within. The music notes translated from the gas are extracted and made audible in radial directions. It's then synthesized into human hearing range through scaling upward from the 57 octaves. This is all captured and visualized by the Chandra telescope in X-ray formatting. After decades of research, Messier 87, an elliptical galaxy, has a black hole that's developed a name for itself in 2019 for the Event Horizon Telescope, though the EHT data is not presented for this sonification, but instead uses data from other telescopes observing M87 around the same time. The three panels correlate to the X-rays from the Chandra telescope, optical light from NASA's Hubble Space Telescope, and radio waves from the Atacama Large Millimeter Array in Chile. The brightest part is where the black hole is located, and the upper right is a jet-produced material falling onto the black hole. The scanning of the sonification is each wavelength mapped to differing audible tones in range. The radio tones from the array are the lowest, optical tones are the medium, and the highest is detected by the Chandra telescope. So, there is sound emanating from space, at a volume we can't hear and possibly can never hear, without the tools we progress to build and use. There is more about this I didn't get to. On Spotify or YouTube, there are uploads of space's noise that NASA has released, such as the rings of Uranus and Saturn's rings, and all planet sounds in the solar system, including moons, cosmic universe, all captured by spacecraft and telescopes.